What's going on, YouTube? Welcome back to LTH. My name is Abe, and in this episode, we're going to cover Linux permissions, okay? And if you would like to learn more about Linux, go check out our tutorial, link down below. We also have a website with copyable commands and instructions and screenshots for some of the items or topics we're covering, as well as we are working on building a community data center together, so go to our project, thedatacenterproject.com, to learn more, and don't forget to subscribe, comment, and like to help this channel grow to make projects like this come to life. Okay guys, so as mentioned, Linux permission tutorial. This might be a little bit longer video, or I may try to go a little bit slower because this topic can be a little bit complicated or hard for individuals to understand. So I went ahead and I used Draw.io and I built this table. So as I cover topics, hopefully I can quick reference this left to right or right to left so you guys understand what I'm talking about a little bit better. So Linux files have permissions defining who can read, write, or execute those permissions. And they're split into three sets. So if we look at our picture, the three sets are the user, who has permissions, an explicitly specified user, a group, which users can be added to, will then all get the permissions that they inherit through this group, and then everyone else on the system that may not be assigned to any group, or it might be a system or a process that is using those world commands, okay? And then over here we have an individual that's not in the three set, which is the directory specified by a D. If there is just a dash here, then it will mean it is a file and not a directory. As well as, normally speaking, you may not see like dash specifying the sets. You'll just have to count over. Okay, this is just for easy readable form. So the first thing we want to talk about is, what does WRX mean? Well, it means read, write, and execute. So the user, for whatever this file may be, can read, write, and execute. Whoever is assigned to the group for this file could read, write, and execute, as well as everyone that's any other person or system could do the same. Okay, and so this can be represented with either numbers or letters. So if we had 4 in the R box, this means the person could only read. And then if this was dash dash, they could not write or execute to whatever the specific file was specified. Now, if they had 6, they could read and write because 4 plus 2 is 6. And if they had 4 plus 2, which is 6, plus 1, which is 7, they could read, write, and execute if it was represented in a number. So as we go through this, I hope that little explanation will help you understand the commands as we type them to make more sense. So I'm going to use the example of lx-l example, which is a txt file we made in episode 2, I believe. And as we can see in here, as I explained, because this is a file, the place for the D is blank because it's not a directory, it is a file. And then the next 3 sets are for the user, read, write, but they cannot execute this file. It is not an executable. And then for whatever the group is, they can read, write, but not execute. And then for the last set, which is world, they can read, but they cannot write or they cannot execute. And so this is good for security. Maybe a rogue user gets into your Linux box, but they did not log in as the user learn. They would be unable to execute. They could simply just read this file. And then this second group is actually the group. So the user learn is under the group learn, and the permissions are set for this folder, for this file, right over here, and then when the file was created. Okay, so I guess we'll leave it at that. Hopefully that makes sense. We will dig into this a little bit more here. So let's say we want to add or remove some of these permissions. So just keep in mind of what's written right here. So I would like to change or modify the permissions with chmod. the letter U is going to be for the user, and then we can use the plus sign to then do read, write, or execute. So remember, we're talking about user, and so the user is what? The first set of 3. So they can read, write, but not execute. So what if we give them executable permissions with the letter X, for example, txt. And then let me go ls this command, and now we can see that the X is now in here. Under the user, learn, he is allowed to now execute this file, although it's a txt, so it's not an executable. Now we can do the same command, chmod user minus X, example file. And if I do that command again, we can see that it's been removed. So it's actually really simple once you start to understand what these numbers mean. Now, we could also do changing this file with those numbers instead of letters, which I know a lot of old school dudes or traditional Linux admins like to do. So we could do chmod 755. So what does this mean? Remember, the first number is going to be for the user group. The second number is going to be, or I said for the user, I should say, to be specific. The second number is going to be for the group, and the third one is going to be for others, or what Linux likes to call world. So what does this mean? The first person, because 4 plus 2 plus 1 can read, write, and execute. Group members can read and execute, but they cannot write. And the same thing here. So let's do this for our example.txt. And what has changed? So we can see in here, if we remember, 5 is read and execute. And so if we go to this group, the second one, we can see they can read, they can not write because there's a dash, but there's an X, so they can execute. Pretty cool. Same thing over here, same thing here. Pretty awesome, right? And I feel like that makes a lot of sense, when, especially once you get the hang of it. You know, you may need to use this cheat sheet for a while, or you could just use the letters because it's a little bit easier to remember. But once again, you can even do that with groups. So chmod G specifically for a group, the plus sign, and then read, write, and execute, for example, if you'd want to give them all 3 at the same time. And now we can see we have read, write, read, write, and execute for those 3. Pretty cool. So if we would want to change the owner permissions now, okay, so now we're talking about owner permissions, and we're no longer talking about setting permissions for the file. So if I do ls-l, once again, example file, remember we have the user learn. Well, I want to do sudo change owner instead of change mod. So in this case, I want to switch it to new user, okay, just like this, and then example file. So now we can see the group is still learn, but now it is a new user assigned to this file. We could also change the owner and the group at the same time, doing sudo change owner, the user learn, and then we will switch this to new user for the group. So we can see they are separated by that colon and then the example file. So now I can see these have flipped. So now the group is the new user group, and it's back to the user learn. So we can do both by just splitting them just like that. And then once again, if you wanted to just change the group, instead of doing change owner, you would do sudo change group, just like that, and then change the group to learn, and then example txt, and we can see now it's back to the original, besides the permissions being a little wonky, okay? So now I want to talk about Umask, okay? This is going to be this table over here. So we can see the Umask table, the chmod permissions table, and we have read, write, execute, and the total value. and then the symbolic equivalent in letters like we just covered. So we're not introducing anything new here. We're simply breaking down our rules in a different way. So Umask controls the default permissions for newly created files or directories by masking out permissions, meaning we are subtracting permissions. Okay? So a Umask of 0022 removes write permissions for groups and others by default. So why are we saying 0022? Because remember, we have 1, 2, 3, 4 sets. So 0, which you technically don't have to write, it'll just get rid of it. We could just do 3, 0, 0, or yeah, 0, 2, 2. And what would that mean? Whatever the number they're currently set to, -2, -2. So if we go back over to our example right here, if I were to do chmod 022, I am keeping this the same, 7. So the owner can read, write, and execute. And then here I'm going to -2, which would make it 3, which really isn't anything, right? Because it's not 4, 6, or 7. And then -2. So that's not a great example in hindsight. So let me show you what I mean by this right now. So let's do Umask like this, and we can see that we have 022, which is our current default mask. And then setting a new mask for temporary sessions, you could do like Umask 027. And so let me show you what I mean by this and setting permissions. I'm going to do touch file.txt, and then let's do ls-l this file txt, and we can see these are our default permissions. So whenever the user learn creates any file, they are going to get read-write, read-write, and then global members or world members will only get read. Okay, so that is the default permissions for this user. So like, let's say you want to give somebody a new account, but every time they create anything, you want it to automatically set these permissions so we don't have accidental privilege escalation, okay? And so let's say you have a user that doesn't really know what he's doing and he creates an executable file, but then he's allowed to execute that file, and maybe it's a script that could damage things on your system. That would be dangerous. Maybe you need a company to come in and audit your system, but you want to only give them read permissions when they access stuff so they can't alter stuff. You could do that by setting a Umask, right? And so in this case, remember, we have 3 sets. So let's do Umask. Remember, 0 is for user. Maybe we don't want it to change, but for read, write, and execute for the group, let's subtract 2. And then for global, we want no permissions, so let's subtract 7. Okay, just like this. And again, this is just a temporary example for the session. So let's do touch Umask file example.txt, click enter, and then we will ls-l Umask files. Okay, and so once again, what did we do? So we subtracted 2, right, from read and write, which is what? That would be 6. We subtract 2, that leaves us with 4. Now they only have read permissions, okay? And then once again, we subtracted 7, so anyone in the world directory cannot access this file, Umask file example.txt at all. And I want to leave it at that because I don't want to overcomplicate it. Just remember, you can read up on it. Umask subtracts permissions by default for a specific user or profile, and that's it. Okay, currently editing Abe here. The way that I explained in the video was, hey, like it was permanent with Umask, but those settings were only temporary. If you want to make them permanent, you have to change your Umask default settings in 3 files just to be safe. So if I type Umask, I have it set to this user to 0333. And what is 7 minus 3, right? So that's 4. 4 and then plus 5, 6, 7. So we're essentially saying the user learn can only read files, which, like my example in the video said, hey, maybe you want to give a company the ability to audit your system and read, but you don't want them to be able to write or execute. You could do that with Umask. So there's 3 places you're going to need to change the specific user's information. So you'll want to be logged in as that user or go to that user's profile directory, but it will be like sudo nano bash rc, like this, select enter, type the password, and we'll go all the way down to the bottom, and you'll type Umask 333, right? And so this will give this person only those permissions. Control X to exit, and it'll be the letter Y, and then enter to save if you made changes. And then you would repeat that process for this folder as well. And then the last folder you would switch is this one. And you would just type Umask 333 in there. And so then you could confirm that those were changed. And just to show that this does work, if I'm logged into root and I do Umask, we can see he has different default permissions. So if I go back here and I do touch umask test.txt, and then I do ls-l umask test, we can see that I just created that file and it gave this user only read permissions. Okay, so that is just one of the ways to protect your system. Let's get on with the rest of the video. Now you could also, add back permissions by doing umask 123, and then we'll do touch umask 123 file.txt, and then ls-l without a space and then we can see it goes back to the default. Okay, so read write, just default. Okay, so that's it for Umask. The next thing I want to talk to you guys about is Setuid, or set the user ID. The set user ID bit allows users to run an executable with the permissions of the file owner, usually root. It is indicated by the S symbol in the user executable permissions place. Okay, so remember that. The user executable permission place. So let's make a, air quotes, executable file. We'll do python script.py. Whoops. Okay, and so let's do ls-l python. If I can keep my stuff straight. Oh, I spelled it wrong. I'm doing all kinds of spelling mistakes, but in here, again, the user, so these first 3 sets, executable permission place. This one right here is blank. So if I want to set this permission, I'm going to do sudo change modification, right? The user plus s, and then the program at which we want to change that to. And so now when I click enter and I check this, there is now a big S right here when there was no longer an S before. So now this user is allowed to execute this script. Okay, and so we can do the exact same thing as this to give executable permissions, but for an entire group. So we could do chmod, G for group, plus executable, and then whatever the slash directory is, shared directory. Okay, so when I'm saying shared directory, I mean you quite literally put in here whatever directory that is. Maybe it's downloads. Okay, and so now everyone that has access to the group directory. Okay, sorry about that. So I just drew a blank, so I needed to Google it. ls-ld for the downloads. And in here, we are looking to see what the permissions are. So ls-l-d for directory, and then our downloads directory will allow us to set the script or to see the permissions to then be able to ensure that our set group ID to allow executable scripts within a directory is accessible. And so the next command we are going to do is sudo chmod g for group plus s to give you executable, and then you need to do the full file path to this directory. So in our case, it will be /home/learn the user /downloads, and then click enter. And then let's look at the permissions of this folder one more time. And remember, since it is the group, we now see an S in that placeholder of executable, which allows anyone within the group learn to then execute script files within the downloads folder. So the last thing that I want to talk about is process permissions. Processes run with permissions of the user who started them. Permissions determine if a process can read, write, or execute files or access system resources. To check processes from a user, use ps-u and then the username. So we can see the user for here. So the ID of the process, so the process ID, the TTY, which we'll get into in a different video, the time at which it was started, and then the command that which was started. So this is going to go into some content in a future video, but I just wanted you to know how to find who is the owner of a process. This also might be good for security purposes because you should maybe have a user or someone who shouldn't be running processes on the machine, but you do, what are all the processes user owns? Oh, maybe there's a username you don't recognize. And then you check what process they're running, and it might have been a hacker who created a new user and then started running malicious files. And you could check that via here through your user management and permissions processes, right? So the last thing I want to talk about is the sticky bit. So when set on a directory, the sticky bit prevents users from deleting or renaming files owned by others within that directory. It appears as a T in the others execute bit position. So an example directory with sticky bits would be ls-ld/tmp. And in here, it slaps it on the very end. We can see the letter T. So this is the root owner in the root group. And then once again, it prevents others from deleting stuff within this directory that are owned by others. And to set a sticky bit on a directory, you would do sudo chmod +T and then the directory path. Okay? Just like that. So that's how you would add that. So once again, to prevent users from deleting or rename files owned by others within a directory. So separation of permissions and duties. That's it for this video. I know it was a little bit longer. Thank you for watching it and being patient and getting a little bit better with Linux. My name is Abe, signing off with another Linux video.